All right, everyone, I wanted to show you this furniture joint I came up with. So usually when I come up with these new joints, before I integrate them into a piece, I'll just mill out a section of it just to try them out. So take a look in the link below and you'll see the table that this joint ended up in. But this is a stretcher, so this would be like a table stretcher, and this is the table leg. And you can see I just did kind of a cutaway drawing and just milled out the pieces that I wanted to test out. So the idea here is I wanted to make a joint with a an exposed bolt here, but a fastener that was inside here but totally hidden. So if we look in the bottom, this is actually the insert that has a thread in it that pulls this together tight, but I'll get to that in a second. I wanted to show you sort of the theory of how this all goes together. So what I wanted was a joint that is plywood thickness agnostic but also holds together really tight. So I'm going to take this bolt off here and explain how this all works. So if we look at the stretcher on the side here, you'll see that the tenon is straight, but if you look really closely, there's a little bit of an angle right here. And the reason why is when you insert this into here, I wanted a little bit of playroom so it slides in really easy, but right when it gets to the end, it'll bottom out, give it a little push, and vertically you get no movement at all. It's nice and tight. The other thing I wanted is, because this is a multiple sheet mill, I didn't want to have to deal with plywood thickness. So when you deal with 3/4 plywood, or really any plywood, 3/4 in particular, you can end up with sheets that are anywhere from, I've seen 0.67 inches thick all the way up to 0.76 thick. So what I did is I designed the width of all of these slots to be 0.76 times 2, so the maximum thickness that a plywood sheet would ever be here, so that no matter what, when you put it in, it won't bind on the side. And the reason why I did that is you don't have control over the plywood thickness, but what you do have control over with a CNC machine is every surface that the machine mills. So the machine mills this profile here, and the machine also mills this opening, which is why we're able to get a nice tight fit this way, but we've got to leave a little extra room this way. And this is so I can just grab any 3/4 sheet of plywood, or if I've got scrap or some blank space on another job, I can tuck in one of these legs and get it done. So it really makes it efficient. And if I want to make a replace a part for somebody, I can just make them a replacement part and it'll definitely fit in their piece of furniture. So let's talk about how this bolts together, and then we'll see how tight it is when it is together. So I wanted a hidden fastener inside this stretcher that goes across, and one of the things I've run into, there's always a chance with threads and bolts and nuts that you cross thread something, or you just get a bad T-nut. That's happened to me before. So I wanted to make this replaceable, but also a really good fastener. So what I did is I milled a slot in here, and this is, don't forget, this is double laminated, so this was milled open on the machine and then brought together afterwards. So this is able to be done in a 3-axis machine. But simply, this is just a T-nut on this little piece of wood. You put it up in the hole like that, and you take this, stick it together, put our bolt in like that, engages in the threads, and you just go ahead and tighten this right up. Give it a few turns here. I'm going to bottoms out, crank it down nice and tight, and you get a perfectly tight joint that isn't going to move anywhere and is super easy to assemble and incredibly strong. So take a look at the table in the link below, and you'll see how that goes together. And this has been a great fastener because I've been able to flat pack these and send them to customers, and they can put them together really easy. One bolt, one tool, very, very simple. Thanks for watching.